A particular brand of tire claims their tire lasts 50,000 miles before needing to be replaced. From past experience, it is known the population standard deviation for all tires is 8,000 miles. A random sample of 64 tires is selected and the lifespan is measured and found to be 53,000 miles. Test the claim that the lifespan of the tire is 50,000 miles. Okay, so what do we have? We've got the null is that mu is equal to 50,000. We've got the alternative that mu is not equal to 50,000. This one's a little bit weird because if they've made the claim that it's 50,000 miles, then they're probably only interested in whether or not it's less than 50,000 miles. But maybe we could argue that they should be changing what their claim is, because if they've got evidence that their tires are actually lasting longer than 50,000 miles, then maybe they can change their marketing campaign and saying, hey, we've got tires that last longer than 50,000 miles. But anyway, the way this is set up, the null is mu is equal to 50. The alternative is that mu is not equal to 50. So what do we have for our evidence? We've got x bar is equal to 53,000. We've got n equals 64. And we've got standard deviation, right? And so this is the standard deviation for all tires. So that's the population standard deviation. So that's sigma equals 8,000. All right, so we're going to do a one sample z-test since we know sigma. So we're going to do a z-test. We're going to check our assumptions first. We have to assume that we have an independent simple random sample, that there's no outliers, and that we have the normality assumption. Okay, well, if n equals 64, so that has to be less than 10% of the population, which it clearly is. There's millions of tires probably of this type. Simple random sample, they told us that a random sample, so we assume so. No outliers. Well, we don't know, so we have to assume that there's none, because we don't have the data. Normality assumption, n equals 64, and that's greater than 25, so therefore we have the central limit theorem. Okay, so we've checked our assumptions, and now we're going to do our z-score, right? So our z-score is going to be 53,000 minus 50,000 divided by 8,000 over the square root of 64. So you can see that that's 8. 8,000 divided by 8 is 1,000. 53,000 minus 50,000 is 3. Right, so 3,000 divided by 1,000 is 3. So we've got our z-score is equal to 3. So the probability that our z-score is greater than 3 is approximately, so let's just go ahead and do the test here. So we're going to go stat, test, z-test. We're going to enter in 58,000, 53,000, 64, and we're doing a two-tailed test. And we calculate it out. There's our z-score of 3. The probability is 0.0026. Notice there's no alpha level, so therefore we assume our alpha level is 5%. So we have strong evidence to reject the null. The tires do not last 50,000 miles. Now that sounds like we're saying they last less than 53,000 miles, right? But we have evidence that they last more than 50,000 miles. They appear to last longer than 50,000 miles, and we're done.